once again, this is your review for your quiz tomorrow and the practice that goes with your your substitution method with these ordered triples. The first section that you're going to look at tells you to determine if the ordered triple is a solution. Show all your work. With these, again, like we did yesterday, you're plugging in your x, your y, and your z to each of the three equations. If you get true statements for all three, it is a solution. If you do not, it is not a solution. So for number 1, for all of these, we're using the 3x minus y plus z is equal to 1, the 2x minus 3z is equal to negative 14, and the 5y plus 2z is equal to 8. For number 1, it gives you the ordered pair of 3, 5, negative 3. So your x is 3, your y is 5, and z is negative 3. So we're going to start with the first equation. That's that 3x, so 3 times 3, minus y, which is 5, plus z, which is negative 3, is equal to 1. The 3 times 3 gives us 9, minus 5, minus 3 is equal to 1. 9 minus 5 is 4. 4 minus 3 is 1. That gives us a true statement. The next one that we have is the 2 times x, which is 3, minus 3 times z, which is negative 3, is equal to negative 14. The 2 times 3 is 6. The negative 3 times negative 3 is a positive 9. 6 plus 9 gives us 15. 15 is not equal to negative 14. So this one is a no. It is not a solution. For number 2, again, we're still working with the same set of functions. We're given the ordered triple, though, of negative 1, 0, and 4. So our x is negative 1, our y is 0, and z is 4. So if we start with that top one, we have 3 times x, which is negative 1, minus y, which is 0, plus z, which is 4, is equal to 1. 3 times negative 1 is negative 3 minus 0, we don't need, plus 4 gives us the 1, so that is a true statement. For your next one, you have 2x minus 3z is equal to negative 14, so that's going to be 2 times negative 1 minus 3 times 4 is equal to negative 14. Your 2 times negative 1 is negative 2, negative 3 times 4 is negative 12. The negative 2 minus 12 is negative 14. So you have a true statement with this one as well. For your last one, you have 5 times y. So 5 times 0 plus 2 times z, which is 4, is equal to 8. Anything times 0 is 0, so that 5 times 0 cancels out. 2 times 4 is 8, and 8 is equal to 8. So that gives you a true statement as well. So all 3 are true statements. This one is yes. For number 3, you're given the ordered triple of 0, negative 1, 3. Again, we're using the same set of functions that we have there. So with this one, your x is 0, your y is negative 1, and your z is 3. So if we start with the top equation, we have 3 times x, which is 0, minus y, which is negative 1, plus z, which is 3, is equal to 1. The 3 times 0 cancels out. A negative times a negative is a positive, so it's positive 1 plus 3 is equal to 1. That gives us 4 is equal to 1, which is a false statement, so this one is no. For number 4, you, again, still working with the 3 equations that we started with. You have the order triple of 1, 0, and 4. So x is 1, y is 0, z is 4. So if we plug these all into the top one, that's going to give us 3 times x, which is 1, minus y, which is 0, plus z, which is 4, is equal to 1. 3 times 1 is 3, minus 0 cancels out, plus 4 gives us 7 is equal to 1. Again, false statement, so this one is no as well. Your next part deals with the back substitution. It tells you to solve the system of equations, write your answer as an order triple. So for number 5, it gives you x minus y plus 5z is equal to 41, y plus 2z is equal to 9, and z is equal to 9. So because we already have one of these variables solved for, we're just going to plug it into that middle equation. So we're going to have y plus 2 times z, which is 9, is equal to 9. 2 times 9 is 18, so y plus 18 is equal to 9. We move that 18 over, subtract it from both sides, and you get that y is negative 9. So if z is 9 and y is negative 9, find x now. Plug both your z and your y into the top equation. That's going to give you x minus negative 9 plus 5 times positive 9 is equal to 41. The double negatives turn into positives, so that's x plus 9 plus 5 times 9 is 45 is equal to 41. Your 9 plus 45 gives you x plus 54 is equal to 41. Move your 54 over. This gives you x is equal to a negative. That 1 turns into 11. Oops, sorry. The 4 minus 1 is 3. 5 minus 1 is, or 5 minus 4 is 1. So it's a negative 13. So if your x is negative 13, your y is negative 9, and your z is 9, this gives you the order triple of negative 13, negative 9, 9. For number 6, we have 4x minus 3y plus 15z is equal to 3, 2y plus 8z is equal to 8, and negative z is equal to negative 1. If we solve for z, we would just move that negative over by dividing it from each side, and that gives us that z is equal to positive 1. Use that to find y. Plug it into the middle equation. That's 2y plus 8 times 1 is equal to 8. 8 times 1 is 8, so 2y plus 8 is equal to 8. Subtract your 8 from both sides. That gives you 2y is equal to 0. Then divide your side by the 2, and y is 0. Use your y as 0, your z as 1, plug those both into the top equation and solve for x. So that's 4 times x minus 3 times y, which is 0, plus 15 times z, which is 1, is equal to 3. The negative 3 times 0 cancels out. 15 times 1 is 15, so that gives you 4x plus 15 is equal to 3. Move your 15 over, subtract it from both sides. That gives you 4x is equal to negative 12. Divide your side by the 4, and that gives you that x is negative 3. So you have an x that's negative 3, a y that is 0, and a z of 1. As an order triple, that's negative 3, 0, 1. And that is your solution. For number 7, you're given 2x minus y plus 5z is equal to 16, y plus 2z is equal to 2, and z is equal to 2. So because you already have what z is equal to, plug that into the middle equation. So it's going to give you y plus 2 times 2 is equal to 2. Your 2 times 2 is 4, so that's y plus 4 is equal to 2. We move the 4 over by subtracting it. We get that y is equal to negative 2. Now solve for x. Plug your y and your z into the top equation. That gives you 2x minus y, which is negative 2, plus 5 times z, which is 2, is equal to 16. Your double negatives turn into positives. That gives you 2x plus 2 plus 10 is equal to 16. The 2 plus 10 gives you 12, so that's 2x plus 12 is equal to 16. We subtract the 12 from each side. That's 2x is equal to 4. Divide each side by the 2, and you get that x is 2. So if x is 2, y is negative 2, and z is 2, this gives us the order triple of 2, negative 2, 2. For number 8, we have 4x minus 3y minus 2z is equal to 21. 6y minus 5z is equal to negative 8, and negative z is equal to 2. If we divide each side by that negative that's in front of that z, we get that z is equal to negative 2. Plug that into the middle, solve for y. That's going to give you 6y minus 5 times negative 2 is equal to negative 8. This simplifies to be 6y plus 10 is equal to negative 8. We move that 10 over by subtracting it from both sides. We're left with 6y is equal to negative 18. Divide your side by the 6, and you get that y is negative 3. Now that you have y and z, plug those both into the top equation and solve for x. That leaves you with 4x minus 3 times negative 3 minus 2 times z, which is negative 2, is equal to 21. 4x stays. Negative 3 times negative 3 is a positive 9. Negative 2 times negative 2 is a positive 4. That gives us 4x plus 13 is equal to 21. Subtract the 13 from both sides. You have 4x is equal to, the 1 turns into 11, making the 2 a 1. So 11 minus 3 gives us 8. We divide each side by the 4, and that gives us that x is 2. So we have an x that's 2, a y that's negative 3, and a z that is negative 2. So our order triple for this one is 2, negative 3, negative 2. All right, so the last two you are asked is the order triple a solution. So same thing as the first section here. For number 9, you're given the order triple of negative 2, negative 1, negative 3. And your three equations are 5x plus 6y minus 5z is equal to negative 1. Negative 4y plus 3x minus 3z is equal to 7. And z minus 2z. This should be x, I'm sorry. This should be x, not z. So x, this is x, minus 2z plus 5y is equal to negative 4. So we're going to plug the negative 2 in for x. So x is going to equal negative 2. Your y is going to equal negative 1. And your z is going to equal negative 3. We're going to start with that top equation. So we have 5 times x, which is negative 2, plus 6 times y, which is negative 1, minus 5 times z, which is negative 3, is equal to negative 1. Your 5 times negative 2 is negative 10. 6 times negative 1 is negative 6. So your negative 5 times negative 3 is a positive 15. So then this would give you negative 16 plus 15, which is negative 1, is equal to negative 1. So this one is a true statement. Keep going with it. Take your x, y, and z, plug them into the middle equation. You have negative 4y, so negative 4 times negative 1, plus 3 times x, which is negative 2, minus 3 times z, which is negative 3, is equal to 7. The negative 4 times negative 1 is a positive 4. Positive 3 times negative 2 is a negative 6. Negative 3 times negative 3 is a positive 9. So this is going to give us 4 minus 6, which is negative 2, plus 9 is equal to 7. That 7 is equal to 7. Again, true statement. So we're going to move on to the third one now. The third one, you have x minus 2z plus 5y is equal to negative 4. So that's going to give us negative 2 minus 2 times negative 3 plus 5 times negative 1 is equal to negative 4. This simplifies to be negative 2 plus 6 minus 5 is equal to negative 4. The negative 2 plus 6 is 4 minus 5 gives you negative 1 is equal to negative 4. So is this a true statement? No. So it's still a no. That is not a solution. For your last one, you have negative 1, 5, and negative 2. That means that your x is negative 1, your y is 5, and your z is negative 2. You're given the equations y plus 3x minus z is equal to 4, x plus 2y plus 2z is equal to 5, and y minus 4x minus z is equal to 3. We're going to work with the top one first. If we plug these values into the top one, it's going to give us 5 plus 3 times negative 1 minus negative 2 is equal to 4. Your double negatives turn into positives. The 5 times negative 3, or sorry, the 3 times negative 1 is negative 3. So this gives us 5 minus 3 plus 2 is equal to 4. 5 minus 3 is 2, plus 2 gives us 4. So 4 is equal to 4. It's a true statement. Move to your next one. You have x plus 2y plus 2z is equal to 5. We plug in our values. That leaves us with negative 1 plus 2 times 5 plus 2 times negative 2 is equal to 5. This simplifies to be negative 1 plus 10 minus 4 is equal to 5. So that's 9 minus 4 is equal to 5, which is 5 is equal to 5. And again, true statement, so check the last one. Your last one, you have y minus 4x minus z is equal to 3. So this is going to be, or we're going to plug in our values, and that's going to give us 5 minus 4 times negative 1 minus z, which is negative 2, is equal to 3. The negative 4 times negative 1 gives us a positive 4, so it's 5 plus 4. The negative times the negative 2 is a positive 2. So that gives us 5 plus 4, which is 9, plus 2 is equal to 3. That's 11 is equal to 3, which again, false statement on the last one. So the entire thing means that no, that order triple is not a solution.